Amachara.
Yes. So, hello everyone, and thank you for this space. This is a previous work of mine. So, I'm Sai Krishna Damalapati from India, Hyderabad, and I work predominantly on public data sets over the last 6-7 years now. Public data sets of various kinds. Started my work predominantly on disaster management, urban flooding, floods in India, and various states in India, and then slowly found other public data works as well. So I worked in law and justice, and then currently for the last 2 years, I'm working on air pollution related work. So this particular talk, when I saw the theme of DataBS, I loved that. Okay, this is not about AI hype, but to actually speak about the messy work that we do. So then I got reminded of one of the very messy works that I have done a couple of years ago. I wrote about it, but really couldn't find a space to talk about this work. But it remains one of my favorite works, so favorite that I got very romantic about it and wrote a poem on it. Uh, so the work was about extracting satellite images from an Indian satellite service called Bhuvan. Uh, this is how the image looks on the platform. So Bhuvan is an Indian satellite service that provides us a lot of disaster-related images. So I wanted flood images for the state of Assam. This is a flood-prone region in the country, and we were working with the government there in providing some intelligence regarding flood risk. And one of the criteria there were obviously flood images were available on Google. Even Microsoft is giving flood images, etc. Even flood prediction were there. But at a government level, they wanted to use official data, which was again Indian government's disaster services data. So this portal has data for several days of the year. For the state of Assam, we found close to, especially in those months that is flood prone, we used to find about every month we used to find 10 to 15 images per year. And today, again, this when I started this work, I was a little new with respect to understanding web map services, geo servers, etc. And also Indian government websites were not well documented. So I didn't know that if I have to access this image, the particular image you are seeing here, today the easy way is to, okay, I know GDAL today, I can just run a single line of code that would, I'll share all the codes at the end, but there's a single line of code. If I write it, I would get this image pretty quickly. But when I started working on this, I didn't know the easy path, so I took a very wrong path and very long path. Nevertheless, I enjoyed the work and actually learned a lot about how web map services work and how actually image, like I learned a lot about image processing, about remote sensing, etc. by taking the dirty route. So what I did when I didn't know the easy GDAL process was, this image you see is the entire state of Assam image. I did inspect the website when I saw on the portal, and after inspecting, I went to the network tab, and in network tab, I saw that okay, like this was one link that I found, and when I copy and paste this link in the URL, the image that you see here, I was able to see something of this sort. Uh, so what this image exactly was is, it is a 256 by 256 pixels image, and we can see in the URL that it has a bounding box coordinates, and the side length of this bounding box coordinate is around 0.0439 degrees, which corresponds to around 10 meters given where the state is. So, which means that now I have such small picture instead of the entire image. I have a very small picture of that image, which I'm able to access using this URL. So the next step I could then do was, okay, for every image I have to get, I took a very long path that, okay, I will download each of these images, because each of this image will then be a URL. As here, I just have to change these bounding box coordinates. The date will remain same for any particular date, and rest others won't need not have to change. So, and again, this is a granular image, like 10 meters is a very good image for a flood image. So I download, this is the entire extent of Assam. So for to get that image, I download each of this image, which is each URL. So I download 13,680 images, and then I stitch them together. So I stitch them horizontally, and then I stitch them vertically. And it was in that process that I actually understood how images are constructed, how I can actually tailor these images, how to process the images, etc. What are the RGB channels, etc. Next challenge I found in this was there were watermarks. Like, I really hated this, and I had to initially struggle a lot working on this. So even those small images sometimes used to have watermarks of the satellite service that was providing it. As I said, it was Bhuvan. So we would see alphabets like B, H, U, V, A, and some of those alphabets in few of those 13,000 images. And the problem with these images when there is watermark is that eventually we want to, basically we are trying to make flood images machine readable. So every pixel, we just want to identify if there was flood in it or not. It was a binary image that way. We would convert these images into grayscale and then just see that, okay, if the particular pixel has flood or not. In these watermarks used to cheat us in those situations, because if there is any value in the pixel, I would consider it as a flooded pixel. But even the watermark was, for a picture, it is just a value, right? So in that pixel used to have values, which means the machine would read it as a flooded pixel. So which was not, we had to delete those watermarks. And again, that was when I actually learned that, okay, an image has, if it is a color image, it will have 3 bands, RGB panels, and then I started looking if there is any pattern for the watermark related images. So I saw that, okay, for the blue colors, the bands were something like this, but whenever there is a watermark, I think one of the bands had a pattern. It had a pattern of 255 or something. So we wrote a code saying that, okay, like that pattern worked. Whenever that pattern matched, it was a watermark, and it was not any other pixel, any other actual flooded pixel. So we then wrote a code, removed the watermarks, and even if we download the entire image using GDAL right now, the watermark problem still remains. So we remove the watermarks and then create a good flood image for the state of Assam in grayscale. So every pixel that has value is a flooded pixel. So this becomes a crucial point for us. Like, okay, for any date that the disaster service portal is giving an image, we are now able to get that image. But it doesn't stop here. We have to georeference the image as well, because this is a PNG otherwise. But to actually get the geo intelligence, then every pixel should also have latitude and longitude value. So we started doing that. We converted the PNG into an netcdf format, and it's like almost like we wrote a code that takes each pixel and gives the latitude and longitude values for those pixels. And then we georeference, plotted it on QGIS, and this is how it looks. Basically replicating what was provided, but in a much more machine readable format, so that we can build further models on this. And then this was for one day, but as I've said, for every year we have multiple images on any given date, in any month. So then we had to build a pipeline that, okay, we download all these individual maps from Bhuvan WMS layer later when I learned about GDAL. So we download all of them. remove the watermarks from them, and then there are certain variables that we want to calculate from these images. So we stitch all flood inundation maps of a month together. So it's like in NetCDF, we can actually add multiple arrays, so it becomes a multi-dimensional image that way. Each layer will be one map of a month, and then we calculate various variables like, okay, what is the intensity of inundation? A revenue circle is just a geographical area. So one is we'll just calculate the percentage area. Okay, if a revenue circle has 100 pixels overall, 30 pixels are flooded in any part of the month, then 30% of the revenue circle is flooded. Intensity of inundation is similarly about how many days, or like if there is a flood on every, if a pixel is flooded on every map produced by the satellite service, then we would count that as a high intensity of flooding. So we had several metrics like that given to us by hydrologists and disaster managers working in the area. So we calculated them and did other parts of the pipeline work. So yeah, so that was my messy data work that I really enjoyed. The codes and further information about this process is in the blog I've written. So people interested can please check that. And that's it. I'm very glad that I can speak about it. It has been there for a while.
Oh, you are missing out on a lot of the chat going on right now, because you can tell that a bunch of us have experience with geospatial data, because we were all like, for example, talking about the decimal places on the coordinates, and someone posted the XKCD about how many decimal points you have in your coordinates and whether.
Let me take it.
I can, yeah, it's at that point it's like if you have like 15 digits, we were like, oh, you have 9 digits, and I had to look up. It's like, oh, that's apparently 110 micron resolution. So it's like, oh, you can point to a bunch of things. Okay, we do have some questions. We have time for this, but we definitely have some questions. So one question is, were all the images of the same quality?
Sorry?
So the map images, were all the images like the same quality?
Yes, quality in a sense.
Yeah, as in like pixel resolution. Were one like did they all match up at least?
Yes, they all matched up. Yeah.
Oh, okay. So all right, that's not.
All the images are also available on the GitHub repository that we downloaded for the last 6 years. Also.
Oh, okay. And so, they were asking like, how can you determine what the quality of the image is? I guess they were thinking about how if you use like Google Maps or something, you zoom in, you get like the low res version and then the high res version and all that. Right. So luckily that was all. That was solving. That wasn't a problem. I remember I was asking like, did those all the images lined up, right? So, like you didn't have like an earthquake that shifted something like just enough that like all the pixels were off.
No, like it was the way the images are encoded in the WMS server, right? So the URL has those bounding box layer as a coordinate. So I just wanted all the images that were uploaded on the server. So I give that was the lowest granularity available. Like when I zoomed into the services, like that, I can share the link. So if you zoom into the services and at the maximum zoom level, that was the link I found, and that was the range of the side length of the bounding box that I found, the minimum possible one. So then I downloaded those images and I was able to stitch it together. And yeah,
that's really good. Yeah, and so Paul was asking, did you have to figure out the map projection when you were going from pixel to lat to long? I mean, it doesn't matter. He's not sure if it matters. So for India, it may not matter as much because you're close to the equator, right? But like if you're way north, things are not square, right? So did you have to make corrections for that, or was it just like, just use the image, it worked out?
Honestly, didn't like when we were doing like workshops on this with the government as well. This didn't come up. Maybe I missed it, but
yeah, I don't know. I've never worked with it in raster, so it's probably probably fine, especially because you're doing differences. So it's like whatever it
Yeah,
is.
so it's just a very small picture, and we basically take the center of each pixel and encode the latitude, longitude for that. And yeah.
Okay, someone asking, do you have any issue with cloud coverage in the imagery, right? Or
Oh,
when
cloud
cloud.
storage. No, again, as I've said, the image is already constructed by the government.
Okay.
So they do the cloud correction. Again, maybe Google has a better flood image, on those particular days. But this project, particularly the client wanted us to use this satellite source because they trust it. It is a government source and they trust this data set. So otherwise, there's no point even to take so much pain to get this data, because like on Google Earth Engine, this data is available much more easily.
So you
So
guys had essentially a known good, or at least you were told to trust it, so good enough.
yes.
I mean, it beats having to sometimes if you're like there's a cloud over this thing and then you can't tell. Okay. Any
Yes.
other
So
questions?
the problem was more like the image was already available,
Mhm.
but it was not easy to access it. So how do we access it and make it machine readable? That was the problem.
Yes. That. All right. Any last questions? We do have about 6 minutes left, but we can kind of chill out while we wait because we did start early, so there's going to be extra stuff. Someone asking 256 pixels squared by 13K blocks. Oh, Libby was asking like how much data was it, like bytes size?
Oh, the entire image size?
Yeah, or just how much data were you working with? Like, are you talking megabytes, gigabytes, terabytes of image data?
It has been a couple of months, I mean years now. But one thing I could do to optimize it was initially, again, the flood image, you can see it was in blue color. So when we initially got the image and georeferenced it, one image was close to 1 GB.
Okay.
I might be wrong, just trying to recollect. But one way we tried to optimize it was, again, simply since we wanted just a pixel to be binary, we really didn't need it to have an 8-bit integer there. So we converted every pixel into just zeros and ones, and also forced that data format, so data type, and that reduced the image size a
Oh,
lot.
wow. Yeah, but yeah, you're just casually like, oh, just one image is a gigabyte, and you had stacks of these images. So a non-trivial amount of data. I mean, yeah, even after before compression, and it's just casually just like, yeah, no big deal.
Yeah, so we did that first, and then obviously did another lossless compressions later on.
Yep. Cool. Any other questions, guys? I'm kind of just scanning around. There are lots. Like if you look at the chat, there's a lot of people who are having fun telling stories about working with geo data because geo is hard. So, yeah, everyone here's like GIS people are cooler than I am, which is because they work and stuff. Okay, but thank you so much for this talk. This was really fun. A lot of people enjoyed it. So feel free to hang around, chat. There's one more
Yes,
question.
thank you.
I am not. That is flame bait. Maddie was like, "What is the correct way to pronounce GIS?" That is yes. So we can leave on that cheerful note.
Thank you.